Hello everyone, welcome to another session on data structure and algorithms. Today we are going to discuss queue using linked list. So when we are thinking of queue in terms of linked list, we will come across the node. Each node is now having info part, the next and previous, okay, so that we can connect them and we can traverse easily along the nodes. As we are keeping track on two ends, this is front and this is rear, front and rear. So two ends we are having with us, front and rear. So in that regard, we'll create the class node now. Class node int info, then node previous as a set procedure structure. We have info part, previous part and next part here. So to insert the node at front, okay, we'll take into consideration two nodes, the new node which is to be inserted and the reference node front. Let's go ahead. Okay, so we'll continue with the method directly without wasting time, as we have already followed the structure. This is front, this is rear, and this is the queue. So we'll insert at the front end, only insert at the front. So we can follow the method quickly. Public static, return type is node, method name is insert, and we'll add node front, which we are going to delete at the front, insert at the front end only. We'll declare scanner class. Scanner is equal to new scanner system.in. Then create two nodes P and Q. Node P equal to new node, the candidate node to be inserted. Then node Q equal to new node for traversal. We'll enter the new node first. System.out.println. Enter info. So in that regard, we'll p dot info equal to sc dot next int. We have entered the value for p, and as this new node is created, p dot next equal to null initially. Okay. So now we'll check. We have passed front. We'll see whether the list is empty or not. Then we'll go ahead. If front equal to null, okay, then front is the new node p. Else we'll make q as a interim node as front. Okay, so this is what we have done. Next we'll move along the queue to reach at the desired location. While and the desired location is always the end of the queue. So we are starting from front, so we'll move along the list to reach at the rear of the queue so that we can insert element. So queue we started from front, so we'll go ahead, queue dot next not equal to null, till it is not null we'll go ahead. So queue equal to queue dot next. So once it is null, then we will reach at the last node. So once we reach at the last node, we'll simply add the element queue dot next equal to p. That's all. So add new element next to last node. Okay, that means the last node is the rear, so we'll insert node at the rear. And as soon as we finish this, okay, so we have to end. What will end? So as we moved along the list, we are following the else part now. So here else we started, we'll end the else here. Okay, so that's how we added element. Now the return type is node, so we have to return the front. So have a quick look on insert operation. Okay, that's nice. Let's go for delete operation. Delete in linked list representation of queue. We have already followed the basic structure of the node: class node, int info, node previous and node next. And once we delete, we will delete at the front for sure. Deletion at linked list is only done at the front, insertion at rear. We have done the insertion at rear, now we'll delete at front. Okay, we'll add the method now, Puji. Public static return type is node, then delete operation will pass front as argument here. Okay, so now before delete we have to check the list is not empty. If front equal to null, if front equal to null, what we'll do? Front equal to null, that means rear equal to null, and list is empty. Else what we'll do? We'll display the element which is to be deleted. Println node to be deleted node to be deleted node to be deleted is the item which is at the front. System.out.println front.info. So this is the element which is to be deleted. So now if we delete this element front, then new front will come which is next to the front. So front equal to front dot next. We'll move to the new front now. So here we end the else part. Okay, now we have moved, then we return the front. Okay, so this is how we delete. The key statement here is front equal to front dot next. That is what we have to follow. Have a quick look here. Okay, so now we'll move along to display the linked representation of the queue. Display key using linked list. So now in this approach we'll follow displaying the list as a single linked list, but here we are having double linked list, but the traversal will start from front and will continue up to the last node, that means rear, and in case of rear node we see the next field is null. So we'll follow public static void display node front node is equal to new node, let's say we have created, is equal to say front. Okay, so we'll check whether the node is empty or not. If front equal to null, that means it is empty. System.out.println list is empty. So now if the list is empty, that's final, but otherwise if the list is not empty, what we will do? Else system.out.println queue is, what is the queue? We'll start from S, which is front. Okay, so while S not equal to null, that means not the last node, what we'll do? We'll simply display the info part of S. System.out.println, let's say we'll print only single line, will print system.out.print s.info. Let's play this symbol arrow mark so that we can exhibit the link. Okay, so now after printing we'll go to the next node, is equal to s dot next, and we end the while loop here. We'll keep on moving till we reach at the node null. Now we'll end the else part as well, and this is the display method. It returning void, and we'll end the method here. So a quick look here. We can follow the linked representation of queue with two ends, front and rear. When we traverse along the list from front, that means start node, we'll move along to the last node, that means the rear. The rear is having the next field null here. So in that regard, we start from front, only if front is not null. Otherwise, we'll follow this while loop. While s not equal to null, we'll print the info part of the node and we'll move to the next node printing like this till we reach at the last node. If we reach at the last node, we'll come out of the list. So two crucial aspects we never forget, that initially your front equal to rear equal to null, and second thing is the rear is with the next part null and the front has a previous part null. But here we are playing no role with rear because only front can make sense. So if from front we'll keep on traversing, we can easily reach at the end by moving to the next node and keeping on printing the node info. That's all for this queue representation of linked list. Thank you.